All right, so we've gone live. Welcome to UACNJ on this lovely day. It's 46 degrees, very overcast, and kind of windy. So tonight we are doing live program both on site and online. So we have our live audience here, and I am actually monitoring chat from my phone for our online audience. A couple things. We are still, next week, we will be relaxing the COVID restrictions just a little bit. Face masks will be up to personal discretion. I, even though I'm fully vaxxed, will be wearing a mask because I have too many at-risk people. But that is up to you guys. We will be relaxing social distancing, but do keep in mind that other people may want to spread out from you. We have discussed this with our board of directors. That is the correct word I was looking for. And we have come to that conclusion that we will be following the state and CDC guidelines. We do have the program as displayed here. You can see it online as well. If you ever miss the program or can't make it to our live on-site program, you can always check us out on our YouTube stream that you could reach through our Facebook page. We normally have a link up when we go live, as well as our website, and you could see what we have coming up on our website as well. We are a completely nonprofit organization, and we do keep going, offering free public programs from donations from people who come to our site. And we actually have a couple of people who have donated because they have seen us online. We do have a small little gift shop for all those fun things and a couple useful things that you may need. We do accept credit cards and cash. If you ever have any questions online, you can ask them in chat or pop them down onto a comment onto our video. We will try and get you an answer as soon as we see it. Or in the case of our online portion, if it's during the talk, we'll ask them at the end for you. If you have them here, we have volunteers around. They are volunteers. We don't pay them anything. We don't pay me anything, though we might sometimes wish. And we would happy to get you an answer or make up an answer if we don't happen to know. I know I'm not the one to ask about the technical issues about, so what's the magnification on that eyepiece? Avoid using bright lights in a way where we're shining them into people's eyes. If you have a light, please point it downwards. That being said, do use your headlights when you leave because it hurts getting hit by a car. We do have the porta potties over there if you need it. And like I said, visit our website. You can check us out on Facebook, Instagram, Twitter. And with that, we're going to get into our presentation. Our presentation tonight is from Paul Fisher. He is our current president of the organization, and he will be doing, you bought a telescope, now what? He has I'm going to say that's a bachelor in engineering.
That's correct.
Yay, I'm learning. In chemical engineering from Stevens Institute of Technology, and has worked in the environmental and chemical industries. Though always interested in celestial objects, Paul's official start in amateur astronomy was one night 8 years ago, lying in an awkward position on his roof in the freezing cold. Probably temperatures similar to right now.
Like today.
Holding a pair of binoculars, he caught a brief clear glimpse of the Galilean moons of Jupiter and was hooked. After some introductory reading, he purchased his first telescope. He is now an active member of Northwest Jersey Amateur Astronomers and volunteers at United Astronomy Clubs of New Jersey. And he still manages to frequently find himself outside at night in awkward positions in the freezing cold, seeing neat stuff in the sky. And with that, here's Paul.
Hi, everyone. There's a lot of people who go directly into investing in a telescope, and now what do you do with it, right? Because there's a lot to learn when you buy a telescope, even if you buy a go-to mount. So let's get into that a little bit. How you can begin to crack that huge nut. And what happened there? Oh, wrong one. There we go. Holy smokes, a war story already. You betcha. Well, and you cannot see it, but unfortunately we're not dark enough here, but maybe online you guys can see it. But along here, you'll see 4 dots along this equatorial plane going through the middle of, this is Jupiter. Those 4 dots are the Galilean moons. And you can actually see them through minimal magnification. If you put a binocular, and if you tip for using binoculars when looking through astronomical or any other object really, hold them at the end. They're easier to hold stable at the end. You want to make sure you're stable. So in a stable sitting position, I was even lying down when I first saw this, was able to look up at Jupiter and see the Galilean moons through on the roof of my house through a pair of binoculars, and a simple device, and I was already being an amateur astronomer. Some things you're hooked. So that's what happened with me. I had that shiver of realization because there's a couple of things about astronomy that are really interesting. Sir Isaac Newton Bernard of Chartres, maybe is the correct way of saying that. If I have seen further, it is by standing on the shoulders of giants. So I myself I have not seen further, but even Isaac Newton acknowledged that astronomy and other things have these giants. So I really saw a glimpse of the history of science. Seeing deep into some of these fundamental truths we've found out as human beings. So really cool stuff. As soon as I saw that, I was sharing a view that Galileo saw, right? So really neat. So Copernicus, Galileo, Kepler, Newton, and others. I'm don't necessarily have the deep appreciation these people did, but I was able to, in some small way, appreciate what very impressive and storied and historic figures were able to see. So what's the point to that story? Why is You Got a Telescope pertinent? Well, here's the one thing that we have to talk about. The geocentric versus heliocentric model, and fundamentally, what is a model? And why amateur astronomy is really, really cool. And let's talk about the models there first. What is a model? It's a simplified representation. It's simplified representations of an imagined reality that enable predictions to be developed and tested by experiment. And that's from the Science Learning Hub. That's not my quote. And also science, and I'm saying this with tongue-in-cheek, science, philosophy, religion, etc. universally agree that humans exclusively use models to understand reality. Now, that's an old philosophical question on how we understand the world around us, right? That is not a settled area of thought. However, we agree that we use models, we can agree that we use models extensively to understand things. So let's talk about back there the heliocentric versus, geocentric versus heliocentric model. And here we go. The geocentric model, of course, is when we thought that the Earth was the center of the universe. We've since all know that, or most of us anyway, know that the Earth is not the center of the universe. That in fact we are heliocentric. Our solar system is heliocentric. Everything revolves around the sun. All right. However, the celestial sphere, and this is where the model portion comes in, still remains a very useful model for us to think about what's happening above us. And the reason for that is because you and I will stand there and our perception really is that the sky is moving above us. And therefore this celestial sphere model is a useful way of thinking about it even though it's not true. All right? And so what is the idea of the celestial sphere? This guy here is the Earth, and the celestial sphere, which is a geocentric model that is not true, but we still find it convenient, is this guy around here, where we imagine the sky is projected above us on this globe of a screen, and we can watch those things go across the sky. And thinking of it that way, it makes a lot of things easier. For instance, this idea of this ecliptic plane in the sky that is perpendicular to the celestial poles, which are around 22, 23 degrees to our our axis that we revolve around. The equator is perpendicular, of course, to the North and South Pole. This ecliptic plane is perpendicular to the solar system's pole. Okay. So yes, here's the South Celestial Pole and the North Celestial Pole. And then here we have the equinoxes and the solstices on various sides of the great circle that goes around the celestial sphere. So another concept I want to get across, besides the idea of models being useful, is that astronomy is big, big, big. You're not going to buy a telescope and become an expert in 2 weeks on how to run your telescope. What has to happen is that you have to very much take the approach of how do you eat an elephant? You eat it one bite at a time. Okay, and that's how you can successfully eat an elephant. So astronomy, if you go out and set up your scope the first day you've had it and you figure out where all the pieces go, call it a success, and don't worry about actually seeing something. Again, you see the moon, you successfully pointed at the moon. Call it a success. And by that way, you build your knowledge one piece at a time, and because you are not going to be able necessarily to find a nebula immediately upon setting up your scope. One bite at a time. Let's talk a little bit about the equipment and understanding the equipment. I like this, and I put this so everyone's familiar, I think, with a refractor, a traditional telescope that a pirate would use, correct? I really like, and this has light paths, the red paths coming into the objective lens, which is the lens in front of the telescope. So those light paths come in. They come to a focal point, and then they're showing you here that there's an image right here at the focal point that this eyepiece is focusing on, which then that eyepiece brings those rays back out to a straight path to your eye. So what's really important there is that it takes, for a telescope to work, this objective lens, but also the idea of this eyepiece. They work in concert to bring an image projected inside the telescope to your eye. That's the refractor. Everyone's kind of familiar with the refractor telescope. Here's a Newtonian. This is another common telescope you'll find. With the Newtonian, those light paths, again, are here. They come to hit the objective mirror. It's no longer a lens in the case of a Newtonian. It's a mirror that is curved. It brings the light path to this diagonal mirror inside the Newtonian. And you can tell it's a Newtonian because that diagonal mirror knocks the light out the side of the telescope. So someone will be looking in the out the side of the telescope. It's probably a Newtonian. People do have additional. Sorry, everyone, for the technical difficulties. People could have a custom telescope, and it might not necessarily be a Newtonian. Probably is. And then the catadioptric, including the Schmidt-Cassegrain, is a very typical catadioptric, where it has two mirrors, sort of like the Newtonian, except the light path. This is a flat or a curved mirror here that puts the light back out the end of the telescope, and then you can see through here. The end of the telescope. It's probably a catadioptric. Now, I'm going to ask you, why, with those two mirrored telescopes, do we not have a hole in what we're viewing, right? Because there's a mirror in the way, right? For both of them, you're coming down, it hits an objective mirror, and then it bounces off another mirror that's in the light path. Why are we not getting a hole in what we're looking at? Okay. So every part of the mirror is seeing the same parallel lines coming from the object. Does everyone see that? So here there's a line coming down, 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 and they're all the moon, or whatever it is you're looking at. And that's why. So this mirror in the way will cause some dimming, because that is a dead area on the mirror. But they're all seeing the same thing. All the light coming from there is bouncing off of this mirror and then hitting that mirror, okay? So they're all seeing the same thing. So they're all seeing the moon. That's why you don't get a hole in the image. All right. All right, so is this correct or not? I'm asking our very crowded live audience here. A telescope's main job is to make small objects that are far away bigger, correct? No, but yes, but that's only a partial answer. You know it was a trick question, right? So it was a trap. So the other thing that a telescope does for us, which is very important, is make dim objects easier to see, brighter when we see them. And this is why, because the aperture gives us light gathering power. So the naked eye is about 3 millimeters radius, and the cross-sectional area ratio, which the light gathering power, we're comparing it to the naked eye. So the naked eye divided by the naked eye is equal to 1, right? However, my telescope is an 8-inch telescope with the radius of 101.6 millimeters, the aperture, the radius squared here. We divide that radius by that radius, and we have almost 1,200 times the light gathering power. So it makes dim objects brighter when we look at it, and we can see it better. So that's a very important thing that our telescope is doing for us. And when I talked about eyepieces, so we're familiar with the objective mirror where the light is hitting first. But what about these eyepieces? So these are all, and I won't read them all. I'll read a couple. The Plossl and say is a very common generic eyepiece. And then proprietary eyepieces exist. These are also common eyepieces. And then proprietary eyepieces exist, such as Nagler eyepieces. What are these things and why are they important? These guys are multiple compound coatings, all the laminations. They exist. They have multiple parts. They can be multiple lenses. They're all designed not only to take that internal image of the telescope and project it to your eye, but they're also designed to eliminate all sorts of image distortion, which we call aberration. The focal length of each eyepiece, that distance you saw between the image and the eyepiece, that focal length is expressed in millimeters. You can have them in both a 1 1/4 inch and 2 inch size standard. Medium grade eyepieces, just if you have purchased a telescope, medium grade eyepieces can rival the cost of a beginner scope's value. So a lot of the value is actually in the eyepieces, especially when you have a set of different eyepieces. These are different specialized eyepieces you can get: a reticle, a barlow, an angle viewer. An angle viewer will make it more convenient for you to look at the image, for instance. You don't have to bend down where the scope is. You can look at it that way standing up. So these are different accessories that also are, similar or are attached to your eyepieces. And then finally, my suggestion is, if you have just bought a scope, is to learn your scope with your default eyepieces first. And a barlow, which is actually a magnification multiplier, might be a good suggestion for your first eyepiece accessory. So a little eyepiece terminology: exit pupil. Exit pupil is the image height exiting the eyepiece. The eye relief is how close your eye needs to be to see a clear image. That is especially important for people with glasses. The apparent field of view and the true field of view. The apparent field of view will be something that you get from the manufacturer of the eyepiece. True field of view is something that you'll calculate in a horrible equation. I didn't put it there. It's really just a simple division, and it'll get you the true field of view. It's related to the focal length and the apparent field of view, and you do that division, and you can calculate the true field of view. And maybe that's later in my presentation. I don't remember. If it is, I can show you why. In any event, besides the calculation, I will show you why that's important to get your true field of view. Mounts is another part of the telescope that you need to consider. The altitude, azimuth. A lot of people start with this type of mount. It's easy to set up and it's intuitive. It's artillery-like. And it's telescopic centric. So in other words, you put it here, you move it up and down, and you point it one way or the other, up and down, this way or this way, and you can find your, works just like our artillery, you can find your object in the sky. The other mount to consider is an equatorial mount. They're harder to set up and they're less intuitive to move. A lot of them have electromechanical tracking. They're sky-centric. They are setting circles and rotational orientation. The idea of the equatorial is that if I set it up here and I point it at an object, the equatorial will move naturally with the arc that object creates in the sky. So if you think about a sun, the sun or the moon, and it makes an arc in the sky as it moves, an equatorial mount, even naturally, mechanically, without any computer equipment, can follow that arc if you set it up correctly. And that's the idea behind an equatorial mount. Then you have push-to and go-to mounts with modern electronics, computers and controllers, for amateur astronomy, that makes your mount choice a little bit less critical. There are still reasons why you'd maybe want to choose an equatorial mount especially astrophotography reasons, to choose an equatorial. Other accessories you might use, a red flashlight, a regular flashlight, a red dot finder, or a fixed focus finder scope. A lot of people you'll see a smaller telescope on their big telescope to help find objects in the sky. The reason is when you are looking through a telescope, you are looking through something like that at the sky, and it's harder to find things. You look through a wider range, you will find the thing that you're looking for, and then you can look through that smaller angle of view at a higher magnification through your telescope, through your main telescope. A green laser pointer helps. Broadband filter can help bring out nebula and stuff like that, so that would be a beginner's filter. There are many other types of filter you can use. A case for your scope to store it, and a bench or chair. Don't minimize the importance of not only the telescope being still, because anyone who's seen anything through binoculars, it sort of looks like this when you look through it, right? A telescope is still. It helps you see the object, but you being still yourself is even better. It helps looking through a telescope, so make sure you get a bench or a chair if you're out seriously looking through astronomy. Let's, at the night sky. Let's talk about some vision tips for when you're amateur astronomying. It'll take 30 to 45 minutes for full adjustment of your rod cells. So, avoid light. And you will not be able to see everything that you can see until 30 to 45 minutes after you're in a dark location. Use averted vision. Your eyes are right in front of you. Not only is that dedicated to color vision, which you're not really using at night, but you also have blind spots there. All right, so use averted vision to see dimmer objects. In other words, if you're looking through the telescope and you want to see the object, don't necessarily look, especially if it's a dim object, don't necessarily look directly at the object. You look a little away from it, then you can actually see it a little bit better. Use motion. You can either move the telescope a little bit. Some go-to scopes actually have a function where it jogs the telescope back and forth, or you can move yourself back and forth a little bit, or your vision back and forth a little bit, your eye back and forth a little bit, and pick up a dimmer object that way. And then the other thing you want to or have in your mind when you're looking at some objects such as nebulae or some of the planets even, or any non-point object, have a thing called surface brightness. So the object will have a brightness associated with it. However, the brightness on anything that has width and height to it is going to have that brightness throughout the object, and you can actually magnify it so much that it becomes dimmer and dimmer because you're looking at smaller and smaller pieces of it. So surface brightness takes, it's a flux of light. It's how much light over a unit area. So that's what's happening. You could actually magnify into it and then not be able to see it because your scope's just not capable of picking up that dim of an object. Let's talk about learning the sky a little bit, and and that celestial sphere. I bought some visual aids. So let's talk about here this fake constellation called Bob the Accountant. All right, Bob the Accountant is if he is along the around the equatorial region of our planet, he will do what most everyone's familiar with. He'll rise in the east, come to a zenith point, and then set in the west. So again, and this is approximately south here. He'll rise in the east, come to a zenith point, and then set in the west. So everyone at home, here's Bob the accountant. However, at the pole, at the North Pole, which the Polaris is around, he'll do the same thing. He'll create a circle that we see in the southern sky around the equator, but he will rotate in a smaller circle. So rising in the east. Did I get that? I probably got that backwards, so let's do that again. East to west. No, I did that correctly. He'll do the east to west thing, but he will go around the North Pole like this. And so constellations that are close to the North Pole might not actually even set. All right, we'll just see them rotate around the North Pole, around the North Star. So how do we get that appreciation for the movement in the sky? By losing the scope. You have a scope, sometimes don't use it. Go out and just look up in the sky and watch how it moves. You can lose the scope and then you appreciate the scope more. You can use navigation aids. I want to talk about your cheating brain a little bit, and then go to sky parties and other events. And let's see here if I, yes, so here are, we'll talk about these other things in a second, but let's go right into the navigation aids. Here is a planisphere. Has anyone used a planisphere here before? Excellent. So probably should have opened this up beforehand. I apologize, but here we go. A planisphere has one quirk about it that a lot of the other navigation aids have, and I want to see whether anyone can pick that out. Oh, actually, let me use this example. It's a lot easier. Oh, if you could get the big one from inside there, yeah, that'd be cool. All right. So this is the planisphere. I want to show you this, and you can use that dial out there and turn any time of the year and the time. You can sort of see what's up in the sky. Here is my mock-up of a planisphere. So the mock-up here has north here, south here, east and west, and this is right off of a planisphere. What can anyone tell me that's weird looking about this arrangement? It's not a circle. The planisphere itself would be a circle, but what about east and west?
They're reversed, Paul.
They're reversed, correct. All right, and the reason they're reversed is because you don't read them like this. All right, so if I were to point this north, why is it telling me that east is over there? That's because you have to look at them like this, because north is this way, and now east is pointing over here, so that's the correct direction. So mentally, you can probably do that in your brain eventually, but sometimes people are a little confused on what, so you don't look at them like a map. Remember, you're looking at that celestial sphere above you, and that's why they're reversed. All their other navigation aids will share a similar property. All right, this is the Cambridge Star Atlas. I was going to reach in my bag of tricks there. I have a copy of the Cambridge Star Atlas. This is a 6th magnitude atlas. That's definitely, you can bring it out in the field. I actually have it in my book bag there, and I'm about to lose all this, so I'm going to grab it. Whoa, thank you. Yeah. Thank you for that catch, Kim. All right, so 6th magnitude is a brighter star. The 11th magnitude is a dimmer star. Magnitude numbers go up as they get dimmer. There are many more dimmer stars than there are bright stars. So this guy is about this guy here. This 6th magnitude atlas is about, you know, a reasonably thick map-like atlas. If you think of any map that you've dealt with regularly, it's about that size. This, you can see, this 11th magnitude of dimmer, including all the stars in here, but many dimmer stars also, is 3 volumes in encyclopedia in size. Not very convenient to take with you when you go stargazing. So realize that as the star atlas gets more precise, the number of stars increases dramatically. All right, so that was going to key me into showing you the Bob the Accountant and the the Planisphere. The other app, which everyone is using nowadays, is Star Atlas Maps. You can use Stellarium is a very popular one. I use Sky Safari. You can download them on your tablets, on your phones, and for your computer. They are either free or a minimal cost. So definitely a good resource. The strength they really have is that you can get this level of accuracy in in your phone or on a tablet, so a lot more convenient to carry around. The other thing is that it will help you with star hopping. It'll have some in between these stars. It'll show a lot of the dimmer stars. So as you're looking through your telescope, you'll actually get a more realistic view of what stars you'll see from a Star Atlas app than you will from a 6th magnitude, because the 6th magnitude map doesn't necessarily show all those dim stars. What things can we look at with our new telescope in the sky? What objects should I start picking? The moon is definitely something you should, easy to find. A lot of people will not find it too impressive that you can find the moon in your telescope. However, that is the closest body to us. The detail you can see on it is amazing. You can see obviously the craters and the seas, but you see craters within craters. You see various mountain ranges and things like that. You'll see various, I find the rays coming out of the craters very interesting. So object impacts the moon and it throws this debris halfway across the moon, thousands of miles. So very interesting stuff to see on the moon. So don't dismiss the moon as a very interesting target. The planets, the 5 usual suspects, the very easy to find planets are, of course, Mercury, Venus, Mars, Jupiter, and Saturn. You'll find those all along the ecliptic plane, that plane that the sun and the moon both inhabit. It's an arc in the sky. One thing I wanted to show you about that, the ecliptic plane and how it works. Kim, can I ask you to be a planet?
Sure, Pat can be a planet with me.
All right. So the ecliptic plane, the solar system is actually arranged where more or less within a few degrees, we're all in a straight line or a plane in the solar system. The Earth will, if you see here, it's at a tilt of about 22, 23 degrees to that plane, that ecliptic plane. Thank you. And it, if you'll see here, that in the daytime, which is this side, thank you, the daytime, which is that time, and the nighttime with the object of the planet, we'll see that the equatorial plane is at a angle to the ecliptic plane, the plane of the solar system, and the Earth here, the sun is kind of low compared to the equator, and the night sky is kind of high, because here's the equator here, is kind of high compared to the night sky. So what time of year are we here in the northern hemisphere? Winter. Okay, so in the winter, now the same object, if you could switch your, the same object, you'll see that the night sky is low and the sun is high. So here we are, summertime. So that's how the sky will work with that ecliptic plane, is that when it's the winter, the stuff near the equator is actually relatively high, but the sun's low. Everyone got it? Thank you, Kim. All right, so the planets, the 5 usual suspects, can be found in that same arc, because we are on that flat plane in the solar system as the sun and the moon. Stars themselves, they have different colors. They're binaries or multiple star systems. You can see the individual stars, actually, if you research it, are actually interesting objects themselves. They're not just points of light. You can see color and other interesting things about stars, including variable stars. Deep sky objects, globular clusters, open clusters. There are 2 different types of star groups. Nebulae and galaxies, all with a basic amateur telescope, are all within reach. Outer planets and the asteroids, with a little bit more work and a little bit more familiarity with your telescope, you'll be able to find those too. And of course, your transient objects with specific views and events, such as comets and things like that, are also something you can catch. So a lot of astronomy, a lot of things up in the sky you can see with your own telescope. Talk a little bit about some other things that can help you start figuring out what to look at with your telescope. Catalogs exist. Has anyone heard of the Messier Catalog? There's the Messier Catalog. Messier's an interesting catalog. It wasn't really designed to be a catalog of things to look at. Originally, it was conceived as a list of things that aren't comets by Messier. So if you saw this thing, he wanted a list of things. Hey, that fuzzy object you're looking at with your telescope, that's not really a comet. However, they're easy to find. They are some of the brighter, and they are very interesting objects. So the Messier Catalog nowadays is used as really your first index of things to look at in the sky. The Ngc Ic Catalog is also another catalog. Here's some of the history behind the Messier Catalog. It was compiled by Charles Messier in Charles Messier was in the 1730 to 1817 range. That was when he was with us. He was a comet hunter. He himself discovered 12. And I said, ironically, it's a list of objects to avoid because they aren't comets. And it originally had 103 objects. It's currently at 110. The Ngc Ic Catalog is a much more extensive catalog. It was originally compiled by Dreyer, who built upon the work of the very famous Herschel family. The Ngc Ic stands for New General Catalog and Index Catalog. It originally had close to 8,000 objects. It was supplemented by 2 major updates, totaling an additional over 5,000 objects, and it has been revised a number of times, and it's called now called the revised Ngc Ic Catalog. Wanted to show you here some things you can see. This is actually took. I'm not an astrophotographer at all, and astrophotographers will maybe laugh a little bit at my attempt here, but this is holding my cell phone up to my telescope looking at the moon. And just this very amateurish, almost ridiculous image, you can tell the level of detail you can see in the moon in your own telescope. And it's actually better than that, and people who actually take good astrophotographers, the pictures they take, the images they take of the moon are truly breathtaking. All right, so stars, these are some of the things you can see. Oh, the magnitude, this is Sirius here. Very bright stars. You can start appreciating the various brightness of stars in your telescope, and then you can appreciate the color. If you see here, this double star system, it's not actually a double, this is a double star, it's not actually a system. You can see maybe an orange or yellow and a blue star right next to each other. You can actually start to appreciate stars have different colors. You can see some of the outer planets. Neptune. You can see some of the galaxies. Andromeda is a galaxy that we'll be able to see later on in the season, and it's actually a very impressive in your scope. You'll be able to see the edges of that galaxy extend across the entire field of view of your telescope. If you look very nebulously with my scope, but some scopes very, very nicely, you can see the entire, not the entirety necessarily of the galaxy, but a good amount of nebulosity across the entire field of view of your eyepiece. Everyone's favorite subject. I told you I'd get to the math, and there's that math equation I was talking about. Magnification equals your length, telescope divided by the focal length of your eyepiece. So focal length of your telescope, which is a manufacturer's item, manufacturer's spec that they'll give you, focal length of your eyepiece, which is printed right on the side of your eyepiece, and you have, voila, that's your magnification. Your true field of view equals your apparent field of view divided by that magnification. And to get started, that's all the math that you need. You can now create an eyepiece chart for your telescope. The other thing you can do, and here's a field of view. Once you learn that field of view, can you guys still see this? Hopefully you can. So here we are. This is a nebulous object in the sky. We're looking, when we measure distance, what's the distance across? We're actually talking about all the amateur and professional astronomers use a angle measurement because we don't know how far that object is from us. All right. So if we know our apparent field of view, our true field of view, we know, say, that that object, we can fit it, say, in here, we can fit it 4 times across our eyepiece, and we know that our diameter, or the field of view that we have, the true field of view that we have is, say, 1/2 degree. then half a degree divided by 4 is how big that object is. You know, with that theta, we know what that is. All right, so that's one real, that's a reason why you would want to know your field of view, and that's why that equation was important. Thank you, Kim. And if we go back, let's see if I can find it quickly. If we go back to here, you can actually set your field of view as a circle on all these apps. You can even go to one of these guys, and if you're mathematically inclined, you can know your field of view for your certain eyepieces. You can actually cut out a circle the correct size, and using a little math, and also do the same thing. And when you do that and you set that little circle on your for your field of view for your various eyepieces in an app like this, you can see exactly on this app what stars you'll be able to see if you point it anywhere in the sky. So you'll know where you are in the sky. All right. And that will come in this one more technique, star hopping. Having that circle, having that field of view calculation will help you with this, which we will come to in the next sky. Let's talk the next slide. Coordinate system madness. Let's talk a little bit about coordinate systems. Unfortunately, legacy things, especially science as old as astronomy, people started applying math to it, and there was very little harmonization between how people did things back when it was harder to communicate amongst everybody. So there are different methods for having coordinate systems in astronomy. They're all being used, and unfortunately you'll have to figure out a little bit between what we're talking about. One way to do coordinate systems in the sky is altitude and azimuth. Azimuth is how far east of north you are in degrees, and altitude is how far you are above the horizon in degrees. That's one way to find things in the sky. Another coordinate system is right ascension and declination. Right ascension is how far east of Aquarius you are, and that is in hours of right ascension. And then declination is how far above you are in the equator in degrees. And right ascension to azimuth is a 15 degrees per hour, or 15 minutes arc minutes per minute of right ascension. So in other words, what is that saying? That minutes and seconds, you remember from math, is a unit of, there's 60 minutes in a degree, and then there's 60 seconds in a minute. So it's a measure of arc. Well, arc seconds and right ascension both have that same designation, minutes and seconds. However, they're not the same units, and they don't agree in the size. So you have to realize that. You'll have to figure that one out and scratch your head a little bit. It takes a while to get used to that. All right, let's talk about star hopping. Yeah, you're not going to be able to avoid it completely. Even if you have a go-to mount, you still have to find the stars in your sky to calibrate your scope. And if something goes wrong, which a lot of times the calibration will get messed up in your scope, you'll have to recalibrate on the fly. So you'll need to know a little bit about star hopping. Plus, you'll actually learn how to find the sky much better. And it's actually fun finding things in the sky the way people used to do it. Here's an example of a real life. This is Vega here. This is the constellation Lyra, and right here is the Ring Nebula. So this is actually a very simple star hopping. You can see you'd go from Vega to here, right to the Ring Nebula, and that's star hopping. So you find Vega, very easy star to find, very bright, and you'd find this star, and you'd go either side of the parallelogram here. This guy's a double star, so it might be the way to go. That way you know you're right on the double star, you're finding the right star, come down here, and then go to the Ring Nebula, and that's star hopping. That's how you'd find the Ring Nebula from Vega. A little bit of homework. I suggest reading any of these books. I read these, and this 365 Starry Nights, very good primer. Start with this one, very good primer. And finally, I suggest joining an astronomy club. You'll pick up hints and just rubbing elbows with more knowledgeable people. Some knowledge will rub off, and it'll make you a little bit more successful in your when you have a scope. Just a brief note about astrophotography. Completely different subject than just plain observing. Very much. The level of complexity increases significantly. It's the other really effective way to gather light, right? So exposure length and error trapping by multiple exposures is what astrophotography is all about. Like I said, the complexity and the expense is at a completely different level, and you are surrounded by skilled astrophotographers here. A lot of our volunteers are astrophotographers themselves. And I just did want to point out here that I was going to explain another way to explain 401, that this object here in Bob the Accountant was another way. So we could find this bright star here. On atlases and maps, the bigger stars are the brighter ones. So this bigger star here might be one you find, and then you could work your way on Bob the Accountant to M401K. All right, so I wanted to get that horrible joke in. And does anyone have any questions on any of that? Because that's it.
All right. Thank you, Paul. Thank you guys for sitting in the audience.
Yes, sir.
Let me bring you the microphone so that the online audience can also hear the question.
Do you use setting circles at all?
I don't have an equatorial mount, so I have an alt-azimuth mount. I have a Newtonian, so I don't have the circles because it's an alt-azimuth mount.
What eyepiece do you use as sort of first when you're searching through the sky? What millimeter size
Yeah, that's
eyepiece?
a good question. You'd want to, especially if you're having a little bit of difficulty. Obviously, you would use your finder scope or dot or your Telrad's excellent. Use your Telrad, but then you want to switch eyepieces out, and you'd want to get smaller and smaller with your focal length to find the object. So the Ring Nebula, I can see it not very well in detail, but I can see it with my 25 millimeter. And then if I want to look at the Ring Nebula in more detail, I'll either slip my Barlow in and double the magnification, but of course thereby decrease my field of view, or put in my 10 millimeter eyepiece.
Right, there was a question online. Let me scroll to it. Do Barlows, you had suggested Barlows earlier. Do Barlows normally come with a beginning telescope?
I think they can. I might have seen that at one point, but they are relatively inexpensive. I think most times they're in the 2 times or 3 times range, and a 2 times a Barlow effectively will double your eyepiece. How many eyepieces you have, because you now have 2 settings for each eyepiece. Different eyepieces, if you remember, have different magnifications. If you have 2 eyepieces and you have a 2 times Barlow, you have now effectively 4 eyepieces.
Oh, hold on. Let me bring the mic so online can hear.
I'd like to make a suggestion.
Yes, sir.
If there's an interest, I think we can offer practical lessons. We can bring a small refractor and a small reflector and show how to operate a telescope so that people could see fully accessorized telescopes, planisphere, star charts, everything.
I think that's a good idea, Igor. The only problem is on a night like this, it would be very difficult to actually show it practically. I think one of a very good suggestion is learning the magnitudes of the stars. Is how they look through your own personal telescope. Very instructive on and helpful in finding your way around the sky. So yeah, I agree. How to move and all that type of stuff. That's a good idea. That's a good idea.
Right. I actually have an interesting question based on my own personal experience. So, say I've somehow won a telescope in a giveaway, or I find a telescope $10 in someone's yard sale, or find it on the curb after Christmas because some kid took it out and couldn't see the moon or something. What are some tips or things I should look for if I'm acquiring a secondhand telescope, such as at a yard sale, or as, oh, here, I don't use this anywhere, here, to know if I have a scope I can use?
Yeah, so if you want to take a serious shot at amateur astronomy, the quality of your scope is going to be very important to your success level. Some of the telescopes that you can get for younger folks are more toys than they are real scopes, and you might get a certain level of frustration trying to use those scopes. That's not to say that a child who may have some interest and you're just not unsure, you're not very sure whether that interest is going to continue. That's certainly an intelligent step to take before getting, making a good investment. But if you're a beginner scope, say in the 4 to 8 inch range, it's going to run you $400, $500, $600, $700, $800 in that range, and that's a Newtonian, that's a Dobsonian Newtonian, Dobson Newtonian, and that scope and that range will actually start getting you pretty good views in the sky, and it's probably worth your investment for a first scope. The other ones, they're going to frustrate you a little bit. They don't have the field of view that you need. The optics are not necessarily great. The accessories, such as a finder scope, you're just going to have that dot accessory to find things. They're not ideal for being really great success starting out your hobby. I would go for one of the beginner scopes that are a little bit more tuned towards the beginner, towards real amateur astronomy. And those references I gave you a little bit earlier, very good. They will point you in the right direction for good beginner scopes.
Yeah, that being said, so what I've gathered from this is the telescope you may find at the yard sale that looks like you could probably get it at Walmart might not be what you want to do. However, if you go to one of the more recognized, well-known brands for quality, I would imagine such as a Meade or a Celestron, for example, would even a lower end scope would be, although not as nice, would still be within an acceptable range.
I think a couple of them still do have scopes in the toy range. Some of them do. I'm not pointing fingers at any particular manufacturer. Both of those are good manufacturers. Many amateur astronomers have those brands. But I would certainly say that you know, do the research. But you know, if you pick up a really good deal at a yard sale, you know, and it's going to cost you, you know, $50 for what looks like a reasonable scope that isn't a toy, you know, go for it, see what happens, because you're probably you know, you may be getting a deal there.
All right. There don't appear to be questions online. Are there any more questions from? Hold on. Let me bring the mic to you so the online people can hear.
Typically, when beginners buy a scope, they think about the tube, and very few people think about the tripod. And you might have optics which will perform okay, it won't be horrible, it will be acceptable, but you might get a very shaky mount. A mount is a very important part of a telescope. If you have a shaky mount, it can kill your experience. This is something to pay attention to.
Thank you, Igor.
Thank
Again,
you.
that's a very good point. And yes, that we did, sorry, Kim. And that was, you know, we did talk a little bit about mounts. Mounts are a very important consideration in your telescope, as Igor said.
Right. So, thank you guys online for watching. Thank you guys for coming out on such a wonderfully clear and beautiful night. I'd say normally we would have a observatory open, but honestly it looks like everyone mostly just wants to go home, get warm.
And it is raining, so it's hard to bring our out. It is a couple of drops here and there, and you really don't want to have your equipment out exposed to actual rain.
Yeah, so I want to thank everyone for coming out. Again, you can check us out on our website, UACNJ.org. That has all of our member clubs. It also has a list of many of our telescopes over in our observatory. It has directions. It has links to programs you can have. It has a list of our all our programs available for this season, so you can check out our list if you are local or going to be visiting the northern New Jersey area. Do check that out. There is camping at the state park if you're interested in camping, and possibly check us out on one Saturday night from April through October. We will be doing live. Luckily, rain held out, so it's not pouring rain, so we were able to do a live presentation. If we are ever, wow, you turned on the sun. If we are ever rained out, we will do a solely online presentation. And even if you miss the live section, like I said, you can always check out our replays or go back to ones you did not know about. So with that, have a good night.